Alright, so the next problem is counting bits, and this is also a bit manipulation. If we look at this counting bits problem, we have given an integer n, return an array ans of length n plus 1 such that for each I, which is in between 0 to n, answer sub I is the number of ones in the binary representation of I. Well, this is kind of like the previous number of 1 bits problem that we did in the last video. If we look over here, we have this input n is equal to 2, and then we have output, which is 0, 1, and 1. Explanation is that it starts from 0, it goes 1, and then 2. Now, okay. Now, basically here we have 0 like that, 1 like this, and 2 like this. And it represents the binary representation for all three of them. If we look at n is equal to 5, it starts from 0, 1, 2, 3, 4, and 5, right? 0, 1, 2, 3, 4, all the way to 5, because it's basically going n plus 1. And it checks the bit for this was 0, for this was 1, for this was 1, for this was 2 actually, for this was 1, and this was 2. So that's why like that. Okay, so this is the constraints. We have the number length from 0 to n, 10 raised to the power 5. Okay. And follow up, it is very easy to come up with a solution with a runtime of O of n log n. Can you do in a linear time O of n, and possibly in a single pass? Can you do it using without using any built-in function like built-in pop count in C++? So basically, these are some challenges I would love for you guys to solve. Put them in the comments of these videos. Now, what we have here is this class solution, and we have a public vector int. So we have a vector int return type, and we have the count bits, and then in here we have number n. So, like, suppose we have 2. Okay, pretty cool. Now, the thing is, that's great, but we need to know how to count this is for like a group of bits. Like, suppose it's like 2, and then goes all the way from 0 to 2, right? But we need to know how to count the bits, like the set bits for a specific number. We already did that in the first, earlier video. So I'm going to rewrite the solution for that, where we had, this is count bits, but we had count set bits for one specific number, right? So what we have is the number. After when we have the number, we create a variable which is count. Okay, we use the Brian Kernighan's algorithm. We check in the while loop while the number is greater than 0. Yeah, so basically greater than 0, right? And in here we kind of like get the number, and we do a bitwise AND operation with 1. Okay, we do a bitwise AND operation with 1. If we get a 1, that we actually add it within the count, and we put that count like this. So kind of like this. So we add the count, and once we do that, we could right shift it. Right shift the number, kind of like n, and then right shift it using this operation with 1. So this is kind of what we want to go about. And then once we have all of the things done, we could return the count like this. Okay? Okay, that's great. Now we have to go here in this problem, which is count bits. Now, in the count bits, we have a vector return type. Okay? And that's for like each number when we want to pass in count set bits. So I feel like what we could do is, first of all, we create a vector of results. Okay? So what we could do is a vector, and we create a vector of ints, and this one would contain the results, right? Like the results you're seeing in the output section, which is right here, right? So vector int would call it results, and we'll put a semicolon here, and then we have a for loop. We go from 0 all the way to n, and then we have incrementation. So I could basically use postfix or prefix. You already know the difference between both. I made a video. This is before increments before the evaluation. Then after that, it does the expression, and and postfix basically first evaluates and then adds up. So kind of over here, it doesn't really affect. What we're gonna do is we're going from I0 all the way to less than equal to n, which is the total number, because we're actually including that number as well. So that's why we have to do less than equal to n, and we have to essentially count set bits for each number. Count set bits using the what is it called? The count n. So we have int n, which is passed like this. But we could actually go from 0, 1, 2, 3 because we know that we have to go. So we could say I. If I just said n, that was just going to count 2, which is right here. No use. I want to go from 0, 1, 2, right? So I could go using the ith incrementer. So 0, 1, 2. It's going to go. If I said 2, it's going to go 0, 1, and 2. It's going to count these set bits, right? And it's going to return their counts. But I have to store them in like a vector. So I have a vector with me, results. I could use results dot push underscore back to add the result answer like this. So put the number inside, or the result like this. So once I do that, I could actually, have the results vector returned. And I feel like this is the entire solution for this problem. If we use control and comma, we check if our solution is correct. If it is, it's accepted. So we have a input of 2. We got this, and the expected was this. If we look at the case 2, and we have an input of 5, we have an output of this, and the expected was this. Superb. And we have control and enter to submit the code, and we basically have it solved. I believe there's no such explanation for this purpose because this was kind of like the same stuff. It's pretty easy. I basically explained it. Thanks for watching this one, and we'll do the next ones in the next video.